Okay, this Zoom session is being brought to you by Fractal or Bullseye
Sir,
Horizon. Yes?
there's someone with noises in the background. It's making it really hard to hear you.
Yeah, Guan, I think it's Balin Guan, please mute your. I'm muting it. Fine. I think that'll
Thank,
help. Yes.
thank you.
Uh, You're welcome. Okay, anyhow, like I was saying, brought to you by the Fractal Bullseye Horizon. Okay, now today we go on. Right, logarithms. Now, okay, we before had talked about exponentials. This is this graph that starts very small and goes through 0 by 1 and 1 by n and zips off to infinity very quickly. That's if a is bigger than 1. And all right, a to the 1, 0 is 1, a to the 1 is a. Now, the logarithm base a of x is the inverse of the exponential base a. A to the log base a of x, log base a to the x is x. So y is the logarithm of base a of x if and only if a to the y equals x. That means the graph of the logarithm and the graph of the exponential look at like each other when you flip through the diagonal y equals x. So here's the graph of the exponential, and here's the graph of the logarithm. It goes through 1 by 0 because exponential goes through 0 by 1. It goes through a by 1 because exponential goes through 1 by a. So log base a of 1 is always 0. Log base a of a is always 1. This goes to infinity very quickly. This also goes to infinity, but very, 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 very slowly. Well, I'll give you a few examples in a moment. So let's do this. I think I better do this class quickly before it cuts out again. Anyhow, log base x of 81 is 2. What's x? All right. Well, okay. Log base x of 81 is 2 means 81 equals x to the second power. So basically, when you transpose a logarithm base x, you get an exponential base x. So 81 equals x squared, so x is the square root of 81, which is 9. Okay, great. Log base 5 of 125 is x, and what's that? Okay, log base 5 of 125. 125 is 5 to the third power. And logarithm base 5 and exponential base 5 cancel. You get x equals 3. Log base x of x to the third equals 3 means x is what? So log base x of 5 to the third equals 3. Transpose a logarithm, it becomes an exponential, base x. 5 to the third equals x to the third, so x equals 5. Log base 100 equals 3 halves. For what x? Well, you transpose the logarithm base 100 and becomes an exponential base 100. So log base x of 100 equals 3 halves means x is 100 to the 3 halves. 100 is 10 to the second to the 3 halves. You multiply 2 times 3 halves and get 3. X equals 10 to the third, or 1,000. Log base x of root 3 over 3 is a half, or what x? All right, so we transpose the exponential. The logarithm becomes an exponential base x. Root 3 over 3 equals x to the half. Square both sides, so that's x. So, and if you do if you do this squaring, it winds up with 3/9, or 1/3. X is 1/3. Log of a million is what? Now, this log with no subscript is called the common logarithm, or log base 10. In a bit, we'll talk. That's a fairly, shall we say, popular logarithm. It's sort of the first one that was produced, and well, close to. And all right, so and I might get, if we have a chance, I'll get it. I'll show you my slide rules, which are based on logarithms, but that'll maybe it'll wait till next time. So this is log base 10 of a million. Okay, a million is 10 to the sixth power. It's log base 10 is 10 to the sixth. The log and the exponential cancel, leaves a 6. Common log base 10 of 1/10 is what? Well, log base 10 of 1/10 is 10 to the minus 1 power. So the log and the exponential cancel, leaves a -1. Log base a half of 1/32 is what? Well, 1/32 is the fifth power of a half. And again, the logarithm and the exponential cancel, leaves a 5. Log base 9 of 3 is what? Well, 3 is the square root of 9, which is 9 to the half power. So log base 9 of 9 to the half power, the logarithm and the exponential cancel, leaves 1/2. Okay, that's it for this. Let's stop this. Stop recording.